Good evening, everyone. I have a great news today. Finally, AmiCube V1 is up and running. I have original Minimig core ready, and as you can see on the screen, Workbench is up and running. I can load data, we can perhaps load sysinfo and do some testing if possible. Let me see. One thing to mention, I'm still in progress of adjusting and programming, changing the Verilog. Even though this kind of looks like Minimig, it's not. It is a new Spartan-6, and oh boy, I mean, there is so much things to change, so many differences in place that it's like building something on a completely different platform, let's say that way. So far, even though I can run Minimig with 100% stability, what I can say, there's still some things to kind of polish. For example, turbo mode works. I can do, this is, I believe, 35 megahertz. So we can try to do that. But there are some changes on the board, and because of those changes I will need to do some further development. For example, now we are using 20 megahertz crystal, and before it was around 4.4, and therefore the calculation and mathematics inside of the Verilog for creating all these necessary clocks is completely different. So that's one thing. Secondly, now we're still using DCMs, but these are next-gen DCMs from Spartan-6, and it's very different. The coding and how these DCMs behave, there's quite a few differences. So here, if you see, for example, this digital counter, it was working 4.4 megahertz. Now it's 20. Therefore, I've added instead of 3.3 volts on this VCC pin, now we're having 5. And for that reason only, now we can use 20 megahertz clock. Actually, in reality, it can go up to 25, I believe. So that's kind of workaround. This will be changed in the next iteration. And now Spartan-6 is getting good clock, stable good clock, and from 20 I was able to calculate all the other clocks that AmiCube needs. However, there's a couple of things. First, I haven't had a chance to do the kind of adapt to I haven't had a chance to adapt these changes to the SAM S7. So especially in the turbo mode, the SPI is kind of unstable because further adjustments are needed because of all these changes. So that's something that needs to happen. Secondly, I made a major mistake just because I never used Spartan-6, and that's the fact that this platform has clock capable pins. And before, with the original Minimig, the compiler, the synthesis and IC just didn't care about if the pin, for example, for generating the clock for 68,000 is clock capable. In fact, it doesn't have that many. But here, compiler is screaming at me, saying, no, don't do that. This is not a good idea. In fact, I've added some constraints to UCF file, and only for that reason I was able to compile. Otherwise, it wouldn't allow. So that's maybe the first thing with the new board V1.1. I'll need to make sure that this clock from 68,000 clock from ARM as well is using those clock capable pins as needed, and then I will be able to make a clock dedicated route, for example, use buffers the proper way, and furthermore. So that's all work in progress, but regardless of that, I can do turbo mode, of course avoiding using SPI and fast SPI during turbo mode because of not yet done factor. I can do 68,000. I was able to run, of course, PiStorm, and later we can even check this AmiCube branded PiStorm 68K, and you'll see just in a few seconds works beautifully. And it's a great addition to this board, and I think I'm going to ship with every single AmiCube. I'm going to include this as well, so people can, it's going to be pre-programmed already. It's going to have also PiStorm on it, so you can just jump in and enjoy. So aside from that, I mean, and you need forgive me, I'm quite tired. You probably can hear it in my voice because I've been working on this for a couple of days. It's been a couple of late nights, and excitement is there because it is quite a big change, a big step forward for this entire project. So I'm still kind of keeping all together, and hopefully I'll be able to deliver this video because I know many of you guys are curious about it. Now, of course, there is, aside from the work with the clocks and improving the routing for the board, I still need to make a couple of adjustments. One is changing polarity of LEDs, and most importantly, connecting the floppy disk interface to FPGA, because module for floppy is done, and now once that's connected, I'll need to change firmware for the ARM to kind of allow mixed use of ADF files and also a new module. So hopefully we'll be able to copy data from ADF to floppy and vice versa, which would be great, I think. So that's hopefully coming. First, of course, I will just port the floppy controller. It will be exclusively working as a replacement for ADF subsystem, but in time, if I can mix and match those two ways of accessing floppy data, that would be great, and that's a goal. Aside from that, I think Holy Grail is, of course, AGA, and that's coming. So now we have 100,000 logic elements in the chip, which is more than enough to fit AGA about 3 times, including CPU. So that's a big deal, and work on that will start right away. I mean, there's no reason to beat around the bush, because I mean, even this thing with the clocking now that I'm working on, the clocks and dedicated routes and this and that, all of that is actually just exercise for what's coming when I start porting AGA core, because I need to figure out clocks before doing anything else. It's kind of important part, especially as I mentioned, for the fact that my experience with Spartan-6 is almost equal to 0. Not anymore now, but I mean, before I really haven't had a chance to do any coding. So that's where we are. I mean, it's I'm quite pleased, and I just cannot believe that we have running Amiga here, and this happened quite quickly. I think within a couple of days of just working on this part. Aside from changing clocks, and clock generator in particular, there was a few more small changes here and there, surprisingly, but aside from FPGA, the challenge was, as per previous video, the syncing between the ARM and the chip, and the fact again that I'm not using clock capable pins for clocks, which was another headache, but somehow seems to be working. Another challenge will be, of course, testing the floppy with these new level shifters. These level shifters are chosen because they have specific characteristics which are perfect for floppy drive logic levels and characteristics of the floppy drive signals. So they're not CBTDs, they're something else, and supposedly they should be the best fit. So we'll see how that goes. And I guess now maybe I can try to start some games. Let's just so we can hear a little bit of intro music, which is always for me a treat, a big treat. Let's say maybe, let me turn on the speaker 80%. And let's try my favorite. So this is always the best way to start Alien Breed. There we go. Okay, so what else I can show you? I mean, in general, seems like everything's connected well and it's working fine. One thing that's on the top of my list is the mouse port. Whenever I power on the board, I need to replug the mouse because I think DCMs now have slightly different mode of operation. At the beginning, they hold clocks on the reset for a certain number of cycles, and then for that reason, I think mouse is not getting clock in those first few cycles, or I think right now it's set to 255, and because of that, I just need to replug the mouse every time I reboot. But this is probably the easiest problem to solve in Verilog, so that will be done first. But once initialized, I can restart like I did now, and mouse working just fine. So maybe I can move forward with this beautiful board, and we can see how this works. Okay, now we have this PiStorm board in place, and you will forgive me the flags and bunch wires and all this stuff, because this is an early prototype. A new production board is coming, already made an order, and I'll have boards within a few days, so that I'll start moving this soon as possible. But let's turn this on, and let's look how the hold will be removed from halt and reset, because now we're in the mode to use 68,000. Here you can see the LED. The booting is still in process, and now that's done, see, which means 68,000 is free to talk on the bus, and PiStorm is on hold, and now you can see hard drive here loading. Since I'm not using fast SPI or turbo mode, it will take a little time to load. I probably need a few more days of playing with clocks before I can be confident in using higher frequency for SPI, or even using turbo mod constantly. But as I said, I'm making progress every day, so it's all about the software now, and there's no really once hardware is in place, everything else is kind of just a matter of time, and it's easy part in my opinion. And yeah, there you go. I mean, here we have 68,000 running, and we can check. Of course, there's one thing that I mentioned, because I just restarted. What I need to do, and I will try to do this with one hand without breaking the board, I need to replug the mouse. DCMs are initializing for slightly too long for a mouse to get a clock, but when I do this, it's all good. So this needs to get done in the Verilog. Execute command. Let's see, we can use command line interface, and then just I guess check for CPU, and it should be 68,000. So 68,000 in action. There you go. Okay, now let's move to PiStorm, and then let's power on. And as you can see, the same thing's happening. The programming, the core is going to its place. There you go. And now the MiniITX programming, and you have, as you can see now, these LEDs are released. So I'm going to show you one more time. So I'm going to restart. I'm restarting again. This is the programming of the core, and then you'll see at some point here. Take a look. These lines should be released. Now 68,000 is being held, and there you go. PiStorm is released, and now we have a hard disk here loading the operating system. So the whole this thing with I have discrete logic made out of out of these transistors behind. So depending on the switch, transistors will, you know, enable certain lines or disable certain lines and all that stuff. So maybe in the future I should just put a small CPLD there and do it better. But you know, a couple of transistors and resistors is fine. Anyhow, we are back in business, and the mouse, of course, is not working because I just restarted the thing. So what I need to do, I need to replug this thing here. There you go. Let's go back. Sorry, it's difficult to do it with one hand, but I'll manage. There you go. And then here we are. So I'm going to execute command, use, and just do CPU. There you go, all 40. Beautiful. It's working just fine. And of course, I mean, it's fully functional. You can play stuff. You can play, let's say, some 32-bit games. Maybe I like showing off Gloom, of course, but you can do Doom as well, whatever I like. And then this is by far my favorite Amiga 3D game. I guess one player, and then let's try to do that decadent full screen window. Because we can, why not? And just butter smooth stuff. That's so cool. What a game. Although apparently this is not really optimized as it should be, because now we're seeing amazing frame rates running on 68,000 in an Amiga computer. So this was not really done well. It's relying now on CPU performance to do this, but in general Amiga can do much better. Apparently, we know that after 40 years. Anyhow, that's PiStorm. So now we'll have a beautiful switch here. It will be mounted on the front. It will have a cover, so you can flip it and do the toggle. I think it's going to look a little bit ridiculous and kind of cool, in my opinion. Although I have also a small switch that can be on the back side and be very discreet. So I'll experiment a little bit with the aesthetics and see how it goes. But this is, ladies and gentlemen, computer having Spartan-6 100,000 plus LEs, fully AGA capable, just waiting for the core to be ported. A lot of stuff needs to be done in Verilog, but again, that's just the software. So with a little bit of time, well, I'll make everything perfect, and we'll have some, I would say, a lot of fun, especially once the floppies are up and running and we can load stuff from the diskettes, relive nostalgia, and have this in some beautiful case. By the way, I didn't mention that. Now it came to my mind. I will probably keep different form factors. There will be the case that's slim, as the one I have right now for Minimig, but because this is AmiCube, it will be a cube-like case. The reason it's going to be cube-like case as an option is because this is AmiCube, and you got it. And of course, because of the floppy disks. So this case will have 2 floppies as well. So you can, do your thing. You can copy diskettes, you can load from diskettes, use this as our archiving machine to protect your data, all sorts of things. So once we have floppy drive fully functional, that's a must. So I'm going to work on that. Hopefully, I don't know if it's going to make you happy. It's going to make me happy. First of all, I'm kind of making it for myself. I always envisioned that, and now somehow it's materializing. So at some point we'll have that. What else? I mean, that's a good, I guess, good beginning. Next few days you will see movements. I'm going to document everything. First, this annoying mouse DCM problem will be removed. I wanted to say DCM delay that's introduced now with the Spartan-6 and the way it functions. Then little things, clocks, we'll work on clocking to kind of figure out the best way to be consistent and use multiple turbo modes as well. Oh, by the way, because now we have more resources in the FPGA, we can also program the menu to have multiple clocks within a menu, so you don't need to compile a different core to go from 31 to 35 to 42, whatever. You'll be able to do that from the menu itself. Why? Because of Spartan-6 has a lot of PLLs and DCMs and stuff. So hopefully I'm right, and that will be possible. Then, of course, straightening up SPI, making sure it's stable, it can run at 24 megahertz, and we need to kind of push this chip to its maximum, which is a long way after the Spartan 3. We are talking again about the modern platform, something that's like long way from where Minimig was. So that's exciting. Don't expect this to be available soon, because of course there's a lot of work here on hardware and software. We're waiting for 1.1 version of board with all these corrections to come, which will be a heavy loader in terms of the development. That's the board that will make sure that all the clocks are handy dandy, that everything's perfect. And then from that point on, it's AGA. We need to port that core as soon as possible, because that's the whole point. Aside from having additional I/O, we all want to have AGA machine that's modern, ATX, that has these abilities to run multiple clocks, multiple boards, and so forth. So that's what to expect. Subscribe if you can. New content is coming now almost every day. You want to be in the loop. Don't miss new progress that's coming. And make a comment if you like. I'll try to reply to every single comment in the comment section of YouTube. And also try to like videos, because that way will spread the word to Amiga community and everyone who is interested in this kind of thing. There is this thing called YouTube, infamous YouTube algorithm that takes all that stuff into consideration. So that's your small way to contribute to AmiCube project, and try to spread the word on social media if you can, Facebook, whatnot, because more people are involved, the better, I think. And with that, I think we can finish this video and just enjoy the bits and bytes running to this magnificent BGA Spartan-6. Isn't this beautiful? I mean, life's good. Thanks again, thanks for the patience, being part of this journey, and hopefully, maybe even tomorrow, talk to you soon. Bye-bye.